Alright, hello everyone. So, in this video, we're going to basically learn how to count numbers. Seems pretty simple enough, and it really is, but we're going to try to, like, really find clever ways to count different numbers in lists because being able to do something like this is important when we get to some of the more in-depth programming that we're going to do later. So in this problem, we can see that it's asking us how many numbers are in this list. And the list is the numbers 1, 2, 3, 4, 5, 6, 7, all the way up to 18. So hopefully we can figure this out relatively quickly. There's, 18. Whoops. Let's do this. 18 numbers in this list. Right? That would be our answer. Like hopefully this is reasonable and we didn't have to think too much about it. So let's try a problem with a little bit more involvement in it. So in this problem, it wants us to show, well, how many numbers are in this list. But really, like if we look at it, it starts at 7, goes up 8, 9, 10, 11, all goes up by 1 each time, ending at the value 29. So, in other words, it's asking how many numbers are there between 7 and 29 inclusive, where the word inclusive means we're including 7 and 29 in this total. So, alright, you could count out every number from left to right, and you'll get that the answer is 23, right? No problem. But what's like a more clever way that we could sort of approach this and figure out the kind of answer in a bit of a faster way than just counting one by one? Well, if we look back at problem number 1, right, where you start at number 1 and then you count up by 1 each time, right? That's really simple. The simplest version of a counting problem you can get. So what if we could take this problem and then convert it into an easy problem like that first one we have? So what I mean by that is, like, let's look at the first couple numbers. 7, 8, 9, 10, so on and so on and so on, up until we get to 28 and 29. Well, how can I transform this list of numbers into a list that starts at 1 and then ends at whatever final number? Because we know from this problem the final number is our answer if we're counting by 1 and going up each time by 1. Well, to get 7 to become 1, you would subtract it by 6, right? Because 7 minus 6 is 1. Well, what happens if I keep subtracting by 6? If I subtract 8 by 6, well, that gets me 2. If I subtract 9 by 6, that gets me 3. If I subtract 10 by 6, I get 4. So on and so on. So we can see it's now a new list of numbers going up by 1 each time. And, subtract by 6 here, we would get 22. And then subtract by 6 over here, we would get 23. And as we can recall, when we have a list of numbers that starts at 1 and we're going up by 1 each time, that means the answer is that last number on the list, in this case 23, just like how it worked out in this first problem right here. So basically, by taking a list that starts at a random number and ends at a random number but goes up by 1 each time, what you can do is simplify it by just creating a list that starts with 1, ends at some other number, by subtracting that same value each time. In this case, we subtracted by 6 each time. So let's see, well, does this trick work every single time? You'll notice also, what is the value of 6? Well, the value of 6 is 7 minus 1, right? So maybe we can sort of use that to our advantage when tackling this next problem. So if you have any two numbers, A and B, where B is greater than A, can we create a formula for determining how many numbers there are between A and B inclusive? We're including A and B in that count. So like basically A is the smaller number, B is some bigger number. How many numbers are between the two? Is there a general way to kind of find this out? So we're going to use the same idea we used in the last problem. So let's think. If I start with some number A, the next number in that list, if we're just counting all the numbers between A and B, would have to be A plus 1. It would be whatever A is plus 1, right? In the last problem, A was basically 7. So 7 plus 1 was 8. And you can probably see where I'm going. The next number would be 7 plus 2, which is 9. In this case, the next number in our list is A plus 2 instead of A plus 1. Right? Because after A plus 1, you add 1 again, you get A plus 2. And the next one would be A plus 3. So on and so on and so on until you arrived at B. Because remember, B is that last number that we're trying to get to, right? We're starting at A, and we want to get to all the numbers from A up to B. And if you want to compare it to the last problem, think of B as, 29. So 7 would be like our A, and 29 is like the B we're using in this problem. Okay. So we subtracted each time in the last problem, right? So we're going to do the same sort of technique again. We're going to subtract A by a value because think of it as just like this progressing series of simplification, right? Like we subtracted 7 by 6 to get 1 because we know from the first problem we did that counting all the from numbers from 1 to something is easy because your answer is just the last number in the list. So to get the list to start at 1, we subtracted by one number less than 7, which was 6, right? So bear with me, right? The number we're going to subtract with is going to be A minus 1. That's the number we're subtracting with every time. A minus 1. This is probably the most complicated part to get because it's so general. We're using letters and not numbers, but just think of it. We are subtracting from A the value of A minus 1. Basically, the next smallest number to A. Just like we did in this problem. We subtracted 7 minus 1, which is 6, right? So that's basically what I'm doing. And just like this last problem, we subtracted by 6 every time. So I know, if I take the same approach, every time I'm going to be subtracting by A minus 1. Subtract by A minus 1. Right? All so on and so on until the very last number. Subtract A minus 1 from that. And you'll hopefully see what's going on when we actually throw this out. So I'm going to erase what I'm going to do, but I just want you to see like how the algebra works. So A minus 1, right? I'm going to take like this part right here and just perform that. a minus a minus 1. So if you remember from algebra class, when you have a negative on the outside of the parentheses, you're going to distribute it to the numbers on the inside. So that is going to become, well, the a in the front stays the same. It kind of looks like a 9, but a minus gets distributed to the a in the inside of the parentheses, so that's a negative a. And then the negative sign gets distributed to the negative 1, so that becomes a positive 1. And hopefully you can see, all right, a minus a would be 0, plus 1 is just equal to 1, right? That's why this is going to work, because now we know that this part of our problem is going to end up equaling 1. Hopefully that makes some amount of sense. I know it's a little tricky to comprehend, but hopefully you're able to follow the logic of that and you have the algebra skills needed to sort of get that. So, this would reduce to 1. And this is going to reduce to 2. You can try to math out if you want to see how it would reduce, but it would be like a plus 1 minus a plus 1. The a's cancel out again, and 1 plus 1 is 2. This one you get 3, etc., etc., etc. I should really have done the a plus 3, whatever. But then we get to this part where we have b minus a minus 1. b minus a minus 1. Well, again, distribute that negative, and what are we left with? We're left with b minus a, and the negative gets distributed to the negative 1 to become plus 1. So really, this list is going to become the following: 1, 2, 3, 4, etc., all the way up to the value of b minus the value of a plus 1. So that's weird. This formula is a little weird, but this is what works, and we can sort of verify that with the last problem, 23, right? So if we look at our values for a and b, right? A is 7, b is 29. I'm going to erase some of this old work since we already have it. Let's just erase that. Okay. So remember, a is the starting value, b is the ending value, and apparently this formula, b minus a plus 1, will get us all the numbers between the two. So let's try it out. B is, well, let me write it out. B minus a plus 1. Well, b is 29 minus 7 plus 1. Okay, well, 29 minus 7, that's equal to 22. Plus 1 is equal to 23, which, hey, that was our answer. You could count it all out. You could, think of it the way we did before, but we do get 23 as our answer. So it seems, like this works. It works according to the logic we did in this problem. So hopefully that makes some amount of sense, hopefully. In the next video, we'll look at how to work with multiples of numbers and sort of use a similar process to simplify the amount of counting that we have to do.